Hi, I'm Phil, and today we're going to look at the M5Stack DLight unit. DLight is short for digital light, and it's measuring the light in lux. So let's go through and have a look at it. The unit itself looks a bit like this. So there's the front and the back, and it's around about $5.50 from M5Stack. And you would use it in all sorts of applications, home automation. I'm going to use it for measurement, since it's given me the value directly in lux. And it supports all sorts of lights, from incandescent, fluorescent, and it can measure all of those with quite a wide range, from 1 to 65,000 lux. And the interface that you see here is a Grove in connection. So we can have a look at it. It's on a I2C interface, and the analog to digital converter is using a 16-bit width. So it's reasonably accurate. And if you can look at the schematic, since it's all open source, some good software, both with the Arduino IDE, and there are a couple of references there that you can have a look at, together with a demonstration. And similarly with the UIFlow, well supported. So the projects that I've got are to just measure the lux value, measure the flicker from a domestic LED light, or even from any other light. And later, I haven't done this one yet, but I would then compare different light sensors. So the projects I've done already include simple lux measurement. And the one I want to show you is this latest one, which is just done this morning. And you can see my arrangement here. It's showing on the last screen here, it's showing the instantaneous lux value, the average of the last 10 values, and it then shows you a graph of the instantaneous value moving along the screen, and the percentage modulation is just shown here. So the objective is to measure the room light in lux, display that on the LCD of a M5 Core computer, and I want to show the waveform, including the pulse, the effect of pulse width modulation behavior of the light. And that value is going to be transmitted to the serial port. So my Windows PC computer, by the Arduino Serial Plotter, will plot the result. So you'll be able to see that there. So for hardware, what I've got is a core, M5Stack Core, a DLight unit, and a Grove cable. And here is the software. We might actually look at that in detail in a minute. So there's the UIFlow, and for the results, I was getting this graph on the Arduino IDE Serial Plotter. So that was okay, that was good. And I was able to get the percentage modulation, and it was showing around about 4 to 5% from the Hue Philips LED lamp. I guess what I'm missing is the color temperature. So if you go to a commercial unit, it can do what I've done, and it also calculates the percentage ripple. So I'll be quite easily be able to measure percentage ripple, but not the color temperature. So it'd be interesting to actually compare a commercial unit. And an example of a commercial unit, I've ordered one today. It's, let's see if we can have a look at it. It looks like this. It's the light meter, and it does all of the things that the project I did, and in addition to that, it does color temperature. But if you go to this article on the web by Alex Fergus, you'll be able to see the impact of flicker, how it's measured, and what are the risk factors in terms of the frequency and the percentage ripple. Okay, so that's just about all from me. I'll just show you the references. And stay tuned because I'll have a demonstration of this. Okay, so if you're interested in this, go to the M5Stack. There's a shop where you can buy it and a wiki that supports it. And there's plenty of information on the web about the effect of light flicker on your health. Okay, that's it from me for the time being, and I'll catch up with you later. So let's have a look at the software of the digital light sensor on a M5 Core computer. So you can see that I've selected on this IDE, which is called the UIFlow, and it's online from M5Stack. So if you go to that website, you'll be able to generate the IDE fairly quickly. So on the left, we've got the screen of the Core computer, and all you do is just paint that. You paint the labels. So I've got the program name going to come up here for label 0, and I'm identifying the measurements. So we've got the lux value for label 1. Label 2 is the average value. It's the average of 10 readings, and the percentage modulation is shown on the bottom. So here's the code, and it consists of a setup area, the loop on the bottom, and the average. So let's just zoom in and have a look at some of that. So the program name goes to label 0 together with the DLight label. So both of those are appended together. And I'm setting the size of the LCD at a maximum for X is 240, and for the maximum for X is 320, and for Y is 240. And I'm going to set 10, a cycle of 10 for the measurements, starting off with measurement number 1. And we show that on the screen, and set up this sets up a communications with the DLight unit and goes for low resolution. And the reason for that is that you get a faster response. So we're getting around about a 10 millisecond response, which is not that fast, but you have to consider that the remote unit has its own computer, does its measurement and calculations, and has to transmit the values back, all within 10 milliseconds. Then for the setup, we just wait and go on and do this loop. So you can see what we're doing here. We're resetting the name of the program each time we go through the loop. And the reason for that is we want to clear and get a nice screen. And this is the measurement cycle. So we go from along the screen. We're going to scroll and set up a graph on the Core LCD of the instantaneous light value that we're measuring. And here we're actually measuring the light and collecting the values and calculating. After we've finished the cycle, we then go and calculate the average value. And when we get the average value, we can then get the minimum and maximum and display all those measurements together with the percentage modulation. And we've got those measurements all happening in the function get the average. So it gets the average value and returns that. And at the same time, it also calculates the percentage modulation with that algorithm. And at the end of the whole process, it then clears the screen and gives us a clear screen. So that's the software. And stay tuned and you'll actually see a live demonstration. Hi, I'm Phil, and I'm going to show you my digital light meter, and it's measuring the flicker of the Hue LED lights. So the light is, the Hue LED light is in this fitting here, and the sensor is a M5Stack DLight Unit that connects via a Grove connection to the core unit, which you can see here. So what you're seeing on the screen, it's a bit hard because we've got the light reflecting it. On the first number that you get here is the instantaneous value in lux. And after 10 readings, I get the average, and I'm showing that on the right here. So that's the average value. And the value here is the percentage modulation. So if the modulation is too high, you can see it's about 4 to 5 at the moment, then that is a measure of the flickering of the LED light. Now we can also see that on the serial monitor. So if we go to this computer and have a look at the serial plotter, you can see how that light intensity measurement is changing. So it's rippling, and you can then measure what the percentage modulation is. Okay, so that's it from now. Bye-bye.